Welcome to the lecture on microstructure formation at different cooling rate. Based on the CCT curve, they analyze how different cooling rates like slow, moderate, rapid influence the microstructure and mechanical properties of the material. CCT curve provides powerful roadmap for predicting the microstructural development during normal and interrupted cooling condition. Continuous cooling transformation diagram of an eutectile steel is shown in below figure. A number of cooling curves are shown on the diagram. The given curves show various cooling rates can produce different microstructure. The curve marked full anneal represent very slow cooling. Here we seen that the first one is the full anneal, and we put the austenizing specimen in a furnace that has its power supply shut off. This rate of cooling normally bring the steel to room temperature in about a day. Here the transformation of the austenite take place at a temperature close to the eutectile temperature, and the final structure is accordingly a coarse pearlite and close to the predicted for an equilibrium transformation. So here in figure we seen that this temperature is the eutectile temperature, and from here when we started cooling of the austenite, then we put the sample in the furnace by switching off its buttons, and then we cool it up to the room temperature. It will take approximate 1 a day, and coarse pearlite is obtained in this situation. The second curve is marked as normalizing. Represent a heat treatment which specimen cooled at an intermediate rate of by pulling them out of the austenizing furnace and allowing them to cool in air. In this case, cooling is accomplished in a matter of minutes, and the specimen transforms in the range of temperature between 550 to 600 degrees Celsius. This structure obtained in this manner is again pearlite, but the basic difference is that now finer pearlite get finer in texture that obtained in the full annealing treatment. Means in normalizing we find the fine pearlite structure, while in annealing we are getting the coarse grained structure. The next cooling curve represents a still faster rate of cooling, such as might be obtained when a red hot specimen is quenched directly into a bath of oil. Cooling at this rate produces a microstructure that is a mixture of pearlite and martensite. So from this diagram we seen that the third line is shown for the oil quenching. Here we seen that the microstructure obtained is martensite plus pearlite, and fourth one is the water quench. Finally, the curve farthest the left in marked water quench represent a rate of cooling so rapid that no pearlite is able to form, and the whole structure is entirely martensite. Means when we are cooling from the water quench, then the formation of pearlite is suppressed and we get total martensite. So from this figure we seen that when we are doing full annealing, we put the austenite at the furnace and bring out the temperature there up to room temperature, and it will take almost a day. And in second case, normalizing, we put the austenite at the air, and now we are get the fine pearlite. The third one is oil quench. We find the martensite and perlite. Fourth one is the water quench. We find the martensite. So requested you please share, like and subscribe the channel if you are right now not subscribed. So now we sum up the class and we'll see you in next important lecture on how to draw iron carbon diagram. Thanks for your attention.